Hi, my name is Yuan. In today's video, I'm going to show you how to add a second channel to your low cell measurement. So, to add a second channel to your existing low cell measurement, what you do is click Add Channels, and then which will bring up the input task you can select. Then click the force bridge, as we'll be using the same sensor in this measurement. It will ask you for the physical channel, which I will choose channel 1 of the same modules as I used in the previous video. And then a new task, input task is created. In this input task, it inherits the signal input range, scale unit, configure scaled, excitation voltage resistance, so on from the previous channel. So as you go in, you can see that how the mapping between the electrical signal to the physical input. It also inherent the device calibration, the offset nulling, and the shunt calibration from the previous device. But however, it does not inherit the calibration, which you still have to do it manually yourself. So right now, I only have one low cell. So I have changed the input from channel 0 to channel 1. So if I run this, currently channel 0 is floating, so it's sitting at 4 kg. So channel 1 has no weight to it, so it's referenced at 0 kg. So if I applied for my 4 kilogram weight, you can see that it will gives roughly a 4 kilogram reading to the result. I can change the configure scale to something different, say -5 and 5, and then if I click OK, this way I halve my input range. So for 4 kg weight, it will display only 2 kg. However, the configure scale for the second channel is independent of the first channel. So if you click the first channel, you see that the value still remains the same. And in fact, if I switch it back to the first channel, channel 0, it still gives me the 4 kg result like before. Second thing I want to look at is the device calibration. So in the device calibration, currently it inherits the offset nulling and shunt calibration from the previous device. What we can do is that. Oh, sorry, I have to stop this. Start again. What we can do is that for the second channel, we can reset the data. So click finished. If we reset the data, and then if we go back to channel 1, we run the code, you can see that the offset nulling comes back. Now it's 3, not 6, because I have changed the scale. So to fix it, and then if we go back to channel 1 again, you see the offset nulling still stays pretty well. So from this, you can see that the device calibration between the channels are totally independent from one another. So last one I want to look at is calibration. So the system calibration, particularly system calibration for the second channel. So now we have this device that it doesn't have the null signal, and then there's an offset, and then it has no shunt calibration, and the configure scale is wrong. But if you do the high level calibration, I have to stop this first. If you do a high level calibration, you can actually manually remove those deficits. So for example, again, right now there's no weight on the scale, so the reference is 0, commit calibrated value. Now I put a 4 kg reference. To my signal. and then click next. So it will commit the calibrated value. Once again, I do not have a reference for 4 kg tension, so I will just use a default value. So it looks a bit funny, but this is just to demonstrate the purpose. So finish. So now if we run the system, you can see now because it has been calibrated, so it sits nicely at zero. So the red line means the second channel, channel 1. So if I put my 4 kg weight, it will calibrate it to the 4 kg weight as well. Yeah, despite the device has not been calibrated and the setting in the configure scale is wrong. So from this video, you can see that you can add multiple channels to your low cell measurements. The configurations might inherit default values from the previous channel, but they are actually independent of one another. The only thing to bear in mind is that they have to share the same, the excitation value has to be the same. The bridge resistance can be different, but that's about it. You can also, the other thing is you can also export your configurations in an HTML file by opening up the property of your configurations and click Generate Report. I can choose to open the HTML report, which will show the channel name, the date it is calibrated, and the sample rate and sample size, and the reference values, and the person who calibrated the device. So this concludes the end of this introduction.